Alright folks, we have put the faucet on. It is now clamped tight. As you can see, these brackets push up against the underside of the bowl here. The nuts are tightened down. I use my adjustable wrench to snug them up pretty good. Again, not over tight, but enough to squeeze down on the front so that I could bring the base down solid with the plumber's putty underneath. And I've got a good seal there. I believe the faucet is positioned where I want it to be in the sink, so that's not going to have to move. Then I took the first of the two supply lines, or the supply hoses I should say, and attached that to the tail, or the stems coming off here. These are hollow copper tubes, and then they have a square head to grab a hold of. I'll explain that in a minute. And then it's a threaded end, and then you just screw your fasten, turn on the hose. Now for this one, for this application, I'm using a 3/8 inch by 1/2 inch connector on this. It's a 16-inch faucet connecting hose. The 1/2 inch will fit on, is the right size for this particular faucet stem, and then the smaller end, the 3/8, will go into the shutoff valve that's going to be under the sink. I didn't get to that yet, of course. One thing I did want to mention with doing this, even though there's a rubber cone inside here, anytime I'm connecting metal to metal with plumbing, with a threaded connection, a male to a female, I usually use Teflon tape. This little white tape here, you can see I have it on the other tail piece there, the other connecting hose. It comes in just a little roll like this. It's not very expensive, very thin white tape. This does an excellent job to prevent leaks. What it does is when you put it on, it gets down in between the threads, and then when you tighten on a nut on it like this, it seals in between those in case they're not, the tolerances aren't completely tight that it'd be waterproof. That will seal it. The Teflon never deteriorates, at least not in practical usage, and it's very simple to put on. For a typical installation with a nut like this, I wrapped it clockwise around the threads, just a couple times around it so that they're covered, and then I can put on my hoses here. Just a couple things with that for your information. To put these on snug, tight enough that I knew they weren't going to leak, I used two adjustable wrenches. One I used for the nut here that was going on, and the other one, a smaller one, it was for this square head on the end of this. You don't want to try to torque the nut too tight or too hard on here, because you could snap this tube right off. So what you want to do is put your other adjustable wrench on the little square head here to keep the tension off of it, so that your torquing pressure is just between here and here. It's not affecting the rest of it. So that's just a simple tip to keep you from breaking something you don't want to break, but still that you get it tight enough that you don't have to worry about leaks. Now let me just say another thing about this connecting hose. Most of the home improvement stores have them labeled. See, this says faucet on it. So, and the dimensional sizes can change depending what kind of connectors you have. This one's pretty much standard for a bathroom vanity. It is a plastic hose, reinforced PVC, and this is actually the cheaper hose to get. You can get braided steel hoses. They're a bit more expensive. The advantage with them is they're more heavy duty, they will last longer, and they're stronger. Since this bathroom isn't going to get a whole lot of use, I didn't see the need to spend the money to get the better ones. Again, we're on a budget here, of course, so I used the cheaper ones because this sink isn't going to be used heavy, so it's not going to have a lot of constant wear and tear on it. I think it'll hold up for a number of years. You do occasionally have to replace these after a number of years. If you start to get a leak, here is a joint right in here that eventually could leak if the rubber wears out in here, or even you know, the seal here where the PVC touches the metal. It is possible that in time that'll wear, and then you'll get a leak. So you just have to change them out. They're not that difficult to do. The hardest part of this is if your sink is in place and it's fastened down to your vanity or to your kitchen countertop. You've got to be able to get a tool up underneath the sink to tighten this nut down. That's where a basin wrench can come in, or if you can squeeze your way in there with an adjustable wrench to do it, that's where it becomes difficult. That's why when I typically put in sinks, I don't fasten them down from the underside. I figure the weight will hold them in place. Now the kitchen sink, that's a little different, but I at least try to put the connecting hoses on first before I drop them in place, so that this nut is tight and I don't need to crawl up underneath there to try to tighten it. The other one is going to hang down lower, so it's easier access to get to hook up to your shutoff valve. This is going to go right in the shutoff valve, and then the other side of the shutoff valve will be my feed line. I have a valve here I can show you. As you can see, this is just going to screw right onto the top there. Then I'm going to put this plastic connecting piece in. I'm running my supply lines with CPVC. It's quicker and cheaper to work with than copper. And also I found that, especially in an old farmhouse where you've got wood that is incredibly dry, the last thing I want to be doing is working in tight areas with a propane torch and to sweat the joints to connect up the copper pipe. So it's a whole lot safer to just use the PVC with the solvent welding. It cuts easy. I'll show you the tools that I use for that. And as far as I know, it holds up well. It's, you know, it's not something that wears out very quickly. So it'll be something that makes plumbing a whole lot easier. I've done plenty of copper piping for both water lines and heating systems, and it's a whole lot more miserable to have to heat up every joint and put your paste and your flux and then your solder on. And especially now that over the last, I don't know, 25 years or so, 20 years or so, they banned solder that has lead in it. Lead had a low melting point. It made the solder easier to install and adhere well. But because they didn't want it to possibly get in anybody's drinking water, it's been banned. You can't even use lead solder nowadays for a heating system where there wouldn't be any human consumption of the water. So it's made it a little more difficult. The solders they have today require a higher temperature. They're fussier to try to get to run properly so that they fill the void so that everything is sealed. I'm sure professional plumbers have tricks to deal with that, but for me it's a whole lot quicker now to just use the CPVC. So when I get to doing this, this will be where I connect up my shutoff valve, and then the supply pipe will go from there. So that's what it's going to look like under the sink. This is just a simple quarter turn shutoff valve, and it'll do the trick. If I need to work on it, I just quarter turn it, the water's off, and everything from here to the sink would be accessible without having to worry about water leaks. So that's the plan. That's the way it's going to go in. But I just wanted to give you a basic idea about how to connect these easily and to make your life a little easier as far as when you do have to replace them. So we'll catch you with the next portion of this. Thanks for watching.